Hi, this project is based on MATLAB simulation of RC circuit in which we need to analyze the charge and current analysis of the circuit. Basically, this project is developed for the battery charger RC circuits which used to develop the charge the battery with its maximum value, like charging reaching approximately 63.2%, the battery cells and the current decreasing to approximately 36.8%. Basically, this is the main maximum and the minimum ratio of the torque basically, which required to involve the relationship of charging and discharging of the battery basically. Okay, so the thing is that the analysis of RC circuits involves the understanding the relationship between resistance, capacitance, and time constant. Mean time constant basically. Okay, so we need to analyze in this project. We need to analyze the complete RC circuit behavior according to the engineers working with electronic circuits. Okay. So I have just written the complete abstract of the circuit right now. And this one is the introduction. Introduction contains basically this project contains the parameters of resistors, capacitors, and the torque. Oh, sorry, tau. Tau mean time. Tau mean time constant. Okay. So the tau is the maximum value of the time constant which provides the circuit's behavior. So this is the RC circuit behavior, charge and current analysis of the circuit. And let me just, yes, I have defined the importance of RC circuits, dynamic behavior, time constant, charging and discharging dynamics, simulation study, objectives, and the problem statements. Next one is the key questions basically. These are the key questions we need, like how does charge accumulate on capacitor over time in an RC circuit? How does the current flow through the circuit change during the charging process? What is the impact of time constant on the circuit response? Okay, the objectives are there and mathematical approach is this. It means that these equations we are using for the charging and the voltage across the capacitor and the current as well. Okay, the time constant for these equations used, everything is defined here, the key mathematical equations, concepts, assumptions. Okay, so the MATLAB simulation results provides us the complete charge time constant according to the resistance and the capacitance value. We need to define the capacitance and resistance value of the time constant. Okay, tau is equals to RC. It means that we need to define the resistance and capacitance values. So this kind of charge versus time, like how the time and the charge is coulombs. Okay, so this is the basically charge accumulation over time in an RC circuit highlights the maximum charge. So this is the current versus time accordingly, and the charge versus time according to the RC behavior circuit. It depends on different values of resistor, resistance, and the capacitance. Okay, see all the values or results are added in it, logarithmic scale as well, and current versus time. Okay, so the discussion and the key observation is that we just follows the exponential curve with the charge increasing rapidly at first and then slowing down as it approaches the maximum value. Implications here, conclusions, and future works as well. Reference. Let me just show you the MATLAB code, which is this one. These are the two MATLAB files. One is the charging of RC circuit. These values we are just defined as a reference. Let me just run in front of you. Just check it. For example, when we run the code, it asks the value of resistance. So let me just add the value here, like for example 0.5 e power 6. Okay, and the capacitance value 1 e power minus 6. See, then we will get the output value of charge versus time. See, charge versus time and the output current versus time. For example, we just change the value of current and resistor value. Here, for example, we just enter the 10 e power 6 and 5 e power minus 5 microfarad, for example. Okay, and then we will get the different behavior like this one. See, these are the charge versus time and the current versus time. Let me just run the second circuit. Second is basically different. We have used different parameters here. For example, we just used here R is 0.05 e power 6, C in farad 1 microfarad, for example. We will get the different values of like the charge versus current, current versus time, charge and current versus time, charge versus time, time is constant. Okay, current versus time. These are logarithmic scale, current versus time, and the charge versus current. So this is the complete behavior of battery charger, like the charge on battery cells with the different values of charger. So the MATLAB code is defined for both cases in different times. Okay, so if you need to ask any question, you just ask me. Thank you.